Hello everyone, thank you very much for watching this video. I'm so happy to record this video finally because it's about Java 14 that has just been released as general available. So let's see which are the features from Java 14 you need to know, and if you like the video and find it useful, don't forget to also subscribe to the channel and share the channel with others because you'll find some other useful videos as well on this same channel. Thank you very much. So let's see and start with the first change in the language, that is the instance of operator. So Java 14 came with a change for the instance of operator. You recall the instance of, you've probably seen it in code. It's not one of my favorites. I avoid using instance of because you usually use it in situations in which you have to do a cast from a more general type to a more particular type. So for example, you have a number and you see this is an integer, you need to use it as an integer, and then you would simply use a cast to change it back to an integer from a number, and you write something like this. So now of course this line will properly work all the time for compiling, but it will generate a class cast exception at execution if inside n you don't actually have an integer. In my case here I have an integer, but if I would have assigned the 10.5 for example, this is a double, and in this case the line would fail with a class cast exception at runtime. So what you would have seen probably a lot of times in code is a test before doing this operation, where the developer would simply check using the instance of if this is indeed an integer. So if inside n we have an integer, then this condition here is true and the code is executed, and then you can simply do whatever you want with your I here, which means that you can print it in the console, and then we will see in the console of course a 10, and this code will never throw class cast exception because inside the block of if you will get only if indeed inside the n variable you really have an integer. So I don't like this. It's not one of my favorites. I prefer avoiding the casting operators, so that's why I avoid this kind of syntaxes in my code, which are not necessarily really object oriented, but I have to say that I've seen it a lot of times, and there are situations in which you still find it, and it's old code out there that you have to maintain. And let's see if you have a better solution. So Java 14 actually comes with a shorter way to write this same thing. So instead of casting it yourself, because most of the times when you actually when you are using the instance of operator was because you wanted to do a cast afterwards. Java 14 changes this, and you don't have to do this yourself. You simply use the variable name just after the type here, and now it's basically the same thing. So the cast itself goes inside the instance of operator. So it's the same thing. It's something that already existed. You could do this before Java 14, but you had to write one more line of code, which was redundant. So Java 14 takes out of our redundancy and makes our code shorter by this. And this is the change on the instance of operator. Now let's write a second example and discuss the second major change in the language, the switch expression. And you know probably switch expression existed since Java 12, I think. So it's not very new in Java 14, but now they are basically generally available. They are no longer in a trial, so that's why we want to show them again. So let's create a second example here, and another main method, public static void main. And you have seen them again here on this channel. If you look back, you will find a video in which I presented them because they were already part of the language, but again they are only now out there as official, so you can use them without any preview flag added. You of course see that I have the preview here. In my case, by the way, the instance of change is in preview mode, so that's why I have to use the enable preview flag when I compile and run my examples. And in my IntelliJ I have done this by changing in the project structure. Here you see I'm using Java 14 with preview to be able to show you the features that are still in preview mode. But the switch expression which was in preview mode in Java 12 and in Java 13 is no longer in preview mode now, and that's the change in Java 14. You can use now the switch expression. Don't forget, the idea of having switch expressions is that switch is no longer only a decisional structure. You can now use it kind as an operator, very similar to how the ternary operator, the Elvis operator, looked like. And when you do so and you want to take out a value, don't forget that you always have to use a semicolon here. And now you can simply enumerate values. So for example, if x is 10 or 20 or 30, remember that in the past you had to have 3 cases for this. Now is no longer needed. You can simply enumerate the values after the case, and you have this nice new syntax with the arrow, similar to the lambda expression, where you just have to follow it with the returned result. And always when you use it as an expression, don't forget that you need to cover all the cases, because y in this case should always get a value. So in my case it's not compiling here because I didn't cover all the cases, and that means that I need to also use a default here and tell to the expression what has to return if the value is not 10, 20 or 30. And of course I can do something like this, so I can return another value, or maybe you have a situation in which you shouldn't get on that case and then you want to treat it as an exception, and then you can simply throw your exception here. Let's assume I use a runtime exception, but generally, you know, it's better to have always your specific kind of exceptions. But you see now it's working. This means that for 10, 20 or 30, y will get the value 100. For anything else, for any other value x would have, the code will throw a runtime exception. So it's your decision how you go with it. Also, besides the arrow syntax here, you can still use the colon syntax, but if you do something like this, you need to use this new word yield that returns basically the value out of the switch expression. So it's a way to return the value from the switch itself. And yield became a reserved type name as well. So that means that if I want to name a method or a variable yield, I will be able to do something like this. But if I would try to create a class named yield, then I can't do this because yield is a reserved type name. It works basically same as the var word, you know, was introduced in Java 10 and then enhanced in Java 11. So as a reserved type name, yield the same works very similar, and that's because yield was already used in the language. It wasn't from the beginning a keyword, so you can't, for example, in this case, change the name yield of the method in the thread class just because now you want to use it as a keyword. So that's why now yield as far is a reserved type name and not a full keyword. But remember this syntax, so you can use both syntaxes. You cannot mix them, however, so you can't use one of the branches with the arrow and the other one with the colon. So you have to decide whether you want to use the colon or you want to use the arrow. But still, very nice syntax, a much shorter syntax. I'm not forced to write a lot of cases one under the other as I was doing previously in the switch. I can still use switch as a decisional structure, but I can now use it such as an operator, very similar to the ternary operator. So a really good enhancement to the language. Again, this was part of the language starting with Java 12, but now is official, general available, and no longer under preview mode. The third one, we'll create a separate example. So example number 3, again with the public static void main, and we discuss the text blocks. The text blocks, again, they are part of the language starting with version 13. So we still have now in the preview mode is the second version in which they are still treated as preview, but hopefully soon they will be also general available. To remind you what the text blocks are, remember that you have situations, and you see again, even if it's not clean code, you still see a lot of cases in which code strings are concatenated to have for example, multiple lines, and you use a lot of pluses operations here, and so on. So you would like to avoid basically writing this kind of code where you concatenate the lines with a plus, and then you have to take care of indentation yourself. If you have code that has indentation, somehow you want to use it statically in your Java code here as a string, then it's a lot difficult. And you have seen, I'm sure you have seen select queries, or generally SQL queries. You've seen like this in code. I've seen it in old code, HTML, JavaScript. Yes, I know it's not okay, it's not clean code, but you find it in a lot, especially in old applications. And for this, it would be much easier if you have kind of a text block operator, and this you have it in Java starting with Java 13, and now it's still in preview mode in Java 14. So now you can simply write something like this, where you have multiple lines inside the text block, and you have also indentation. So for example, if I use indentation for this set phase here, then the indentation will be kept. So let's print it out. Okay, you print it out and you see clearly here that indentation was kept. Basically, indentation is based on the either the most left part of the string, either the end operator here. So if I put it like this, it will be even more indented in to the right. So this part will be indentation in this case. If you run it, you will basically see how the result changes in my console, and it will be shifted to the right. Yeah, because all of this is indentation. And of course, theoretically, you can have empty strings with text blocks if you write something like this. Then this is an empty string at the moment, but you will clearly not do something like this, because then you have 2 lines to only have an empty string. So it's an unfortunate choice. In this, you can't do something like this. You can't have on the same line the beginning and the end operator of a text block. So these are the main syntax rules for these text blocks. So let's see and hope they will be general available soon, maybe even in the next version of Java. We'll wait for that. The last, but maybe the most impressive change in Java 14, we have now a new kind of a structure that is called a record. So the record is basically something very similar to a final class, but you don't have to write that much code to specify it. Now, if you have ever used Lombok, it's something like having a class with the data notation above, something like this. So let's maybe see it better to see which are the changes that came with records. I will start by creating a class. You see that already IntelliJ here allows me to create the record type here, because it's a preview feature in Java 14, and I have it available. But I will start with a class, and I will create my very favorite class, which is the cat class. You might have seen me writing this cat class a lot of times in my examples. So I just, let's say, create the class, and I define 2 fields for the class. I have a name, and I have also an age. And then if I made the fields final, then I have to, of course, create a constructor for both. And then I made them private, so I will continue the encapsulation, and I will create a getter for them. I can't create a setter because they are final, and maybe I want to make the class itself final so that nobody can inherit it. And this is basically something very similar that I can write in only a couple of lines of code with a record. So if I want to write the same thing with a record, let's create the dog record for this. I will create a new class, and I will create it as a record. A record is created using the record keyword. So dog You see, instead of a class, I write record. This is automatically final. Record cannot be abstract. You see here the very strange syntax, strange at least from the Java point of view, because you've seen something like this in other languages. For example, in TypeScript, you might have seen something similar. But here is what you would have written basically in the constructor, as the constructor parameters. So for example, in my case, a name and the age, if I want to have the same fields for my dog class, I will enumerate them like this here, and what happens is that automatically now my dog has a name and an age which are final, and we can use them. So what else has to be known about records? Very important, a record cannot extend a class, so you can't extend any class you'd like here. You see, it doesn't even allow me to write extends here. I can't write extends because I cannot extend anything with a record, but I can implement method. I can implement interfaces. So for example, if I decide that my dog record has to be comparable, then I can use the implements, and I can implement the comparable, and then I have, of course, I need to override, in this case, the compare to method. Override, here it is, and I have to override the abstract method, and then I can implement this very similarly to how I would have done it with classes. So I can't extend classes, but I can implement contracts, I can implement interfaces. Okay, let's take it out for the moment to keep it simple. And you see how short is the syntax now comparing to the huge class, the huge 20 line class. Here I only have a couple of lines that represent barely the same thing. So in my example 4 class, I will try to create an instance of the dog. So I can write something like D1 new dog, and of course I need to give it a name and an age. So it works very similar. You can see it is barely just a normal class, and you can now get the age and the name. Very interesting is the fact that the getters and the setter, basically there is no setter, sorry, because they are final. The getters aren't named anymore starting with a get. They are simply named precisely with the name of the field. And that's interesting, because now I've seen somebody complaining, should we still call them getters in this case? Maybe we'll continue to call them getters because we are used to call them getters, but indeed it's a little bit strange because now we don't see that get word before the name of the method, and the method is simply the name of the field with, of course, the syntax for the methods. And by the way, if you want to override these getters, you can do that. So you can generate basically your own getters here. If you really want to do so for some reason, you just go here and implement the getters. Just be careful that they have to be named precisely with the name of the field. So the names of the fields here should be the same as the ones given for their methods. So that's a big difference. So you can still, if you feel you need it, you can still implement the getters, but they look a little bit different. In most of the cases, basically we'll use records mainly because we don't want to do that. So I guess that the record class will be as efficient as possible if it is as short as possible, because that's basically what the purpose is. And of course, thinking about Lombok, there are a lot of other features in Lombok still, but we are getting closer to saying that we might in the future not need to use such a library anymore, which from my point of view is a good thing, because we will take out some of the dependencies, and the simpler the project is, maybe the better is to also understand. We don't need annotations, specific annotations to that. We have only directly the structure defined in the language, and we don't have to use any other kind of third-party dependency to implement this. And in a lot of cases, we could say that in projects we were using Lombok for this kind of implementations, for taking out the getters and the setters. So it's already a big part implemented from the language point of view now that we can use records, which is really nice again. So don't forget, the rules for the records are, they are final, they cannot be abstract, they cannot extend the class, but they can implement interfaces. You have this unusual for Java syntax where you have the round parentheses just after the name of the structure, but here is where you enumerate the fields automatically. You have getters for those and the constructor for them as well. And you have seen how I did instantiate here the class. By the way, I've used the var word because I can, but you could have simply used the dog instead. So both work very fine. This is it. Thank you very much for watching this video. I hope it was a short enough video to not bore you a lot, but you have seen the main changes, at least in the language. We have other changes as well. Maybe one of them we should discuss. Let's create a fifth example, and this is the last one, I promise. And one that I like very much, because I always ask myself, once I've seen it implemented, why wasn't actually been implemented a long time ago. It's not related to the language, it's a JVM change, but you will like it for sure. Is the they call it the helpful null pointer exceptions. So let's assume that you have a situation in your code where you have a method. I will make it a static method so that I can call it from the main. So M1, and here I return a new instance of example 5. You can clearly see that this is not null, so not null. It's no wonder why. And I call it from here, and then I want to have a similar method. I will make it this time non-static, and here I return null directly. So I think it's clear now that this is null. Okay, no wonder why. And then I can have as many methods as I want, very similar here. And for example, this third one, maybe it's a void one, and then I just system out something. And imagine this situation. I call M1 from M2 from M1, and then M3, and then I can have a long spaghetti code where I do a lot of differentiations. And yes, this is clearly not something that you want in your production code, but unfortunately you will see, especially in old applications, you will find a lot of situations in which 3 is maybe the smallest number of differentiations on the same instruction. I have seen in the past long lines, maybe on a couple of lines, only doing differentiation. 6, 7, 9, 10, doesn't matter. And the problem with this, of course, the problem is that the code looks like that, but the biggest problem is when you have an exception, especially a null pointer exception, like in this case, you might have spotted that when I will call M3 out of M2, because this is clearly null, this is null, which means that this will cause a null pointer exception. Okay, that's clearly probably null pointer exception. And let's prove it. I will just run it, and let's see, we have a null pointer exception. And the problem with this null pointer exception that it tells me nothing about who was actually null here. Because if you get this from your client and you have an ugly production code and you want to find out what the problem is, and you have 10 differentiations on this instruction, which will tell you basically the same thing. A null pointer exception occurred on line 6. So this actually means nothing for me, because I don't know if this one was null or this one was null. And in my case, I have only 3 differentiations, so I have only 2 objects that can be null. But if I had 7, then it would have been worst. So with this improvement that I have to enable it, by the way, is not enabled by default. So I have to edit my configuration and add an property here. I have actually stored the property in my file here because it's a long one, and I don't want to write it so that I don't have mistakes. So is this show code details in exception messages? So if I enable this, let's see what happens without changing basically anything. So take another look at my exception here and run it again now. Okay, now it got longer, and it says not only that I have a null pointer exception on line 6, it also tells me that I cannot invoke M3 because M2 was null. So basically it tells me where is that null, where is the null pointer exception coming from. So it's a lot of improvement, especially again when working with old and ugly code. And it works basically with anything, like even if you have an array, for example, if you have such an array, and let's assume I only create the first one and I specify nothing here, is clearly here that I have an array with 3 nulls. So if I would, for example, try to assign a value on x of 0 and 0, this compiles well, but it will throw a null pointer exception at the execution because this one, the first part of it, is null because I didn't specify length here. So now it's basically not instantiating the arrays inside. So if I have something like this and I have this nice property added to my VM properties, then it will say, okay, I cannot do that because this one is null. So it tells me precisely where I have the problem. And without this implementation, I simply had a line and a null pointer exception, and nothing was telling me what precisely was null there, what precisely was causing the null pointer exception. Okay, so I think with this I have covered not only the 4 important changes in the language itself, but also this nice part, this nice change in the JVM. There are a few more changes there that you would like to read. I will share with you a link also on the community tab of the channel. So if you want to read the full descriptions for all the changes. And of course I'm waiting for your questions, so if you have a question, don't hesitate as usual to ask it and to discuss with others on the community tab of the channel. Thank you very much for watching, and I hope you enjoyed this video.